Before we start using the trapezium rule in GCSE style questions, we need to remind ourselves of how to work out the area of a trapezium. In your formula booklet, you will be given this formula for the area of a trapezium. In the starter questions, in question A, I could label the two parallel sides of the trapezium that I've been given, A and B, and the perpendicular height of the trapezium, that is the distance between those two parallel sides, as h. I could then substitute the values into the formula, half a plus bh, and that will give me the area of the trapezium. We should get 65 centimeters squared. In question B, it might not be entirely clear what the shape is, but it is actually a trapezium because it has two sides that are parallel, the 7 centimeter side and the 8 centimeter side, and there is a perpendicular distance between them. This means that this is also a trapezium because it has only one pair of parallel sides. Again, we can use the formula half bracket a plus b, so I'm going to label a and b the two parallel sides and h the perpendicular distance. 8 plus 7 times 6. I get half times 15 times 6. And if we put them to a calculator, you should get 45 centimeters squared. The trapezium rule is used to approximate the area underneath a curve. This curve is the curve y is equal to x squared. So as we can see, when x is equal to 1, y is equal to 1 squared, which is 1. When x is equal to 2, y is equal to 2 squared, that is 4. When x is equal to 3, y is equal to 3 squared, which is 9, and so on. What we want to do, what the question is asking us to do, is to find the area, or approximate the area, between the x-axis, the curve, and the line x equals 6. So that means it wants the area going from, I'll just shade it in here, it basically wants this shaded area. To do this, we're going to use the trapezium rule, which essentially, at this level, boils down to splitting up the graph into shapes whose areas we can work out. So we want to use the ordinates. Ordinates just means x values, x equals 0, x equals 2, x equals 4, and x equals 6. So that means we need to draw straight lines going up from 0, but of course that's just going to be at 0 because it hits the graph. A straight line going up from x equals 2 until it hits the graph. Straight line going up from x equals 4 until it hits the graph. And a straight line going up from x equals 6 until it hits the graph. We then join up the lines at their endpoints, that is, the points that hit the graph. This will form a triangle, a trapezium, and another trapezium. As you can see, the area underneath these three shapes quite closely approximates the area underneath the curve. So if we work out the areas under these three shapes and add them up, we get a good approximation for the area under the curve. I'm going to label each of the shapes. So the first one is a triangle, the second one is a trapezium, and the third one is a trapezium, A, B, and C. I'm going to work out the individual areas and add them up. Shape A is a triangle, a right angle triangle. The base of shape A is 2 units, 0 to 2. The height is going to be 4 because when x equals 2 on the curve, y is equal to 2 squared, which is 4. So obviously this is not drawn to scale. To find the area, I need to use half base times height. So I do half 2 times 4, which is going to be 4. So the area of A is 4 square units. B is a trapezium, and I'll just sketch it here. The trapezium looks like this. The left parallel side is 4 in terms of height. The right parallel side occurs when x equals 4, and if you can read off, you can see it's going to be 16, which is what we'd expect. The distance between the two parallel sides is going to be 2 to 4, and I can substitute my values into the formula to work out the area. 4 plus 16, times 2. So the area of B is 20. And to work out the area of C, it's very similar. I know that let's give it a quick sketch here. The left height is 16. The right height is 36. The distance between the parallel sides is 2. So to work out the area, I need to do half 16 plus 36 times 2. 1/2 times 2 cancels out. 36, 46, 50, 52. So the area of C is 52 square units. To work out the total area, I need to add up. To work out the total area, I just need to add up these individual areas. So I have 4, 20, and 52. So that will give me 50, 70. That will give me 76 square units. So my answer would be 76. You might have a function like this, which slopes downwards, but the principle is the same. So we are told to find the area enclosed by the curve, the x-axis, and the lines x equals 0 and x equals 5. We want to use the ordinates x equals 0, 1, 2, 3, 4, and 5 to work. What we do is draw lines at the points of the ordinates. So when x equals 0, I'm going to draw a straight line up from x equals 0. I'm going to do the same at x equals 1, x equals 2, 3, 4, and 5. What I would do then is label the individual areas A, B, C, D, E, and then work out the individual areas. So for A, we have half 30 plus 29 times, and then it's just going to be 1 because the distance between the two parallel sides is just 1. So we just need to do 30, 40, 59, half 59, 20, 29.5. For B, we're going to have half 29 plus 26 times 1. 49, 55, half of that, 27.5. For C, we have half and then 26 plus 21 times 1. 47, 20. That should be 23.5. For D, half times 21 plus 14 times 1. So 20, 35, half of 35 is 17.5. And then E, you have half, and then 14 plus 5 times 1. Half of 19 is simply 9.5. We would then add all of these up to get our final answer. I get an answer of 107.5 square units. Here is a question for you to try. Please pause the video now and have a go. When you're ready for the answers, press play. Here is the answer.